Well, I might post it twice. Okay, so domain kind of got the squiggly line, right? Squiggly bracket, right? And domain, what did we say domain was? Independent, so just the x values, right? So with anytime you're listed like a table of values or just a series of points, you're only interested in the x values, right? So the domain in this question, you simply just get to go, okay, well, -2, -1, 0, 1, close the squiggly bracket, right? But each of these is asking for the domain and the range, right? So we got to, the range is going to be the y values, right? Okay? So you just get to list them. Anytime you have a series of points like this, you just list them, right? Okay, so we're going to list -5, 10, 15, 20. That make sense? Okay. Now the next question, I'll ask you an extension question after the next one. Okay, but the exact same thing, right? So I'm going to take domain. I'm just going to write the D, right? And I'm going to write my x values. Now here's the catch this time, right? Am I going to write all of them? No, right? Because I have repeating x values, right? So with the domain now, I just get to write the 0, the 1, and the 2, right? I don't have to write these two because they're the same x value, right? So my domain in this question is going to be 0, 1, and 2. Okay? And then, if I look at the y values, they're -1, 1, 2. Okay? Again, I don't have to write the other two because they're repeating. Okay? So the range is going to be -1, 1, and 2. Is everybody okay with that? Okay. So if I were to ask you, let's say these points were on a graph somewhere, would this be would B be a function?
No.
No, right? Because I'm repeating y values. No, sorry, not repeating y values. You can have multiple y values. It's multiple y values at any given particular x. That's what's important. Okay. So I have multiple x's, right? I have 1 and I have 1, in which I have two different y values. So it wouldn't be a function, right? Okay, are we okay? The pictures are kind of interesting now, right? So we get to do this. You get to like isolate these again. So the domain is simply much like the last question, right? So you get to look at, okay, well, x can be 3, can be -2, could be 1, 2, or 3. So you have 5 domain values, right? Because I'm just looking at each of these points. I'm strictly looking at where they fall horizontally, right? So from left to right, I'm looking this way. This is my domain, right? And then I just start reading off x values. Okay, well, there's -3, there's -2, there's a point at 1, -1 and 1, 2, and 3, right? So my domain is going to look like this. -3, -2, -1, right? 1, 2, 3. Okay? And then with the range you're just going to look opposite, right? So you're going to go along your y values, and you're going to look sideways and start reading off numbers, right? Sideways. So you're like, okay, well, goes in there. There's one at -2. There's at -1. There's at 1, 2, 3, and 4, right? I see points. So then you get to go, okay, well, I'm just going to write them down. -2, -1, 1, 2, 3, 4.
Do negative numbers always reverse?
I wouldn't be too picky on that, actually. You could start at the top and come down, or you could kind of start at the bottom and go up. These ones are a little bit more flexible in the way that you write them because they're just numbers, right? Okay, so are we okay with that one? Those ones are still like, that's not bad because we're just looking at X and Y values and then listing them, right? Here's where things start to get messy for people, okay? So like, I'm going to do the domain in red still. I'm going to leave domain in red, okay? And here's what I think. And the circle's perfect. I'm going to go to the circle first, and then we'll fill out the rest of them, which I guess we're going in order. But domain and range are like kind of, where can I, like, if I could put a box around the function, that's my domain and range. It's the edges of the box, right? That's domain and range. That's it. That's all you have to know. So I'm looking at the circle graph, and I'm like, okay, the domain. Where can I draw my box lines on that graph that contain the function, right? So I can look here, and I'm like, okay, well, I'm going to go to x equals -3, and I'm going to draw a vertical line there, right? Because I know the graph isn't going to go any lower than -3, right? And then I'm like, okay, well, how high up does it go? Well, I go over to the other side, it just goes to 3, right? So there's my domain. It's never going to go less than x equals -3, and it's never going to go more than x equals +3, right? So my domain's going to look like this, and this is where we're starting to get into some of the formality, okay? I'll explain these in a minute, okay? You're just going to... I'll explain all this in a minute. Okay? So, those are just fancy little letters, okay? And I'll write this down somewhere. And I'll go to the bottom of the lesson, okay? X, the way this reads, so when you read this, it's X, it's like a backwards 3, okay? And it literally reads like this. X, right? This kind of means is a part of, okay? And then this little fancy R thing, it's got like a stick, and it's like an R with an extra stick in front, capital R. It simply means the real numbers. Okay? So we're just like, it's like a sentence, but we're not going to write the sentence every time, right? So we just write this kind of formal statement that represents a bunch of words, right? So let me go back up, and I also had this like vertical line here, right? That means such that, right? So you're going to read this as a big sentence. If you were to communicate this with somebody, right? And then this is just your normal thing, like the little alligator that eats things that are bigger, right? So this piece always trips people up. This always trips people up, but I always write this the exact same way, okay? Okay. This always takes on the exact same shape, and then you fill in the numbers, okay? And I'll explain it here. So I always start in the middle, right? And I read outward. So I'm going to start and say, well, x has to be, if I'm starting here and going this way, x has to be greater than -3, but it also has to be less than +3. right? So if you always start in the middle and then read sideways, left and right, that's going to make sense, right? Does that make sense? You want me to do that again? This is the hard part of it, right? So like, but if you write it the same way every time, right, you just get used to writing number, and the other part is like, these are always facing the same direction, right? They're always going to look like this.
So this, you just have to remember like the outside numbers.
Yeah,
Like
those are the outside numbers are your boundaries that you for your box, right? So then you're going to go, okay, well the rest of this is like a number, which is just a number, right? Is as it's and then you're really going to read out from the inside out, right? Okay, but you're always going to kind of like read from the middle and come down. So it's x is greater than one particular number, right? Or x is going to be less than a particular number. Okay, that's not really a great represent. The important part's this, right? The top half. This isn't really that great. I'm not happy with that, but we'll just do it the same way. And the more of these you do, they follow the same pattern every single time, right? So if we looked at the range, I'll do the range in blue now. Everybody okay with the domain? So they're just the edges of your box that you can draw.
In the order, like the 3x3 thing.
Yeah.
That's the same thing every time.
Every time you're going to write it like this. You're always, I could even do this every single time. I could go, okay, well, it's going to be a number less than or equal to x less than or equal to a number every single time. And then the way you actually read it to people is like, I'm going to stand here in the middle. I'm going to say x has to be bigger than the number on the left, and it has to be less than the number on the right. Does that make sense? Okay. That's honestly like, it's the easiest way. Sorry, were you guys right now? I remember struggling with this for no reason at all, right? Like it's just write it the same way every time, and it's clearly communicated. You never lose any marks, and it's like it just is what it is. Okay, so then I can go. I'll do the range now, right, in blue. Okay. I'm going to erase that because it's in blue. So now I don't care about the x. I'm just going to look vertically like I did over here, right? So I'm just looking up and down. So I'm like, okay, well, how tall is my graph? And like, what's the lowest point it reaches, right? So then I can finish off my box. The circle's perfect because it's the box, right? So I can go like this. Okay, well, it's never going to go any lower than -3, right? That's also never going to go any higher than +3. So my range, you just have to switch the variable for this particular question. So it's y is a part of the real numbers such that y has to be greater than -3, greater than or equal, but also less than or equal to +3. Okay? You think of these things in box, and maybe sometimes you can't fully contain them in a box, right? That's fine. You're still just looking at their boundaries, right? Which you'll see that in E. Okay? Is everybody okay? So then the parabola, interestingly enough, is always going to have the same domain. Okay? So if I look at this, can I, like a parabola technically has arrows on the end, right? Unless it's actually physically said, right? So it's like it's going to go forever vertically and sideways. So your domain for a parabola is never going to change, right? Unless I tried to trick you and didn't draw the arrows or something, which I'm not going to do, right? But the domain for this one, I can't contain it. It's going to go in X forever in both directions. So my domain for this one X is a part of the real numbers. That's it. All of them. right? Because I can't contain it. It's going in both directions in x forever. So it's a part of the real numbers, right? And the range I could put a little bit of a box on, right? If I look down here, the parabola is never going to reach lower than -2, right? So my range is a little bit trickier this time, right? But it's still going in the positive direction forever, isn't it? With the arrows, right? So that's like, it can't go any lower than -2, so we're just going to write YER. Y is a part of the real numbers such that y is greater than or equal to -2. And that would be the only instance in which you would switch the order of those alligator signs, right?
You don't have to write that it is infinite on that one.
No, the domain implies that,
Okay.
right? So when I look at the domain here, I'm like, okay, they didn't contain the top of this thing, right? It doesn't look like this one.
Yeah.
So that's implied. So it's a part of the real numbers, and it just so long as it's greater than -2, right? That's what's great about domain and ranges. It's like you don't necessarily need the graph in order to get kind of a mental image as to what it looks like, right?
Sweet.
Okay. Okay. Same thing here, right? This is basically a parabola, but it's just the absolute value of x, right? That's what the graph looks like. So again, it should have a similar domain and range, right? It's going to go in both directions in x forever. So the domain is going to be x is a part of the real numbers, right? And the range is it can't go below 0 for y, right? It gets stuck here. So then the range is just going to be YER such that y is greater than or equal to 0. Okay. If that graph was opening down, then it would be like YER such that y is less than or equal to 0 because it's open in the other way, right? So all the y values are going to be less than 0. So you just flip this little alligator sign around, right? If it was upside down. Okay. Everybody okay? This is like, honestly, like I think I've put a lot of thought into this, and like I've struggled through this through high school too, and I think this is maybe the best way that I've ever come up with explaining it. This like notion of the boxes, right, and containing the functions. If you can contain them, that's domain and range, right? So this one here is a little bit more subjective, but it's much like the stuff we were doing the other day, right? So it's actually the same. These are all the same pictures from the other day, like lesson 1, right? If you notice that, right? So if we look at this, it's just a simple list of the values again, right? I notice under x, if I'm looking at x here, x will continue to be red. I will try to maintain that, right? I see 4 different x values, right? So you just get to list the domain with this one. So the domain, it's not a part of the real numbers, right? Because they're exclusive x values. Does that make sense? So the domain is just simply -1, 1, 2, and 4. Does everybody understand why I did not write XER? Okay. I can write XER for some of these graphs, right? This one in particular, right? Because it's continuous. Right? The graph's continuous. So it's taking on all of these x values along the way. It doesn't matter if it's -1.5, doesn't matter if it's 0.5, doesn't matter if it's 0, right? It can take on any value along here for x, which is why I'm able to write XER. Right? This is not the case. This is just a series of points, right? These are not, if you look up here at this question, these weren't all connected somehow, right? right? Doesn't make any sense. So you have to list them individually. Okay. So then the range is just you list the other ones on the other side here. I'm trying to fit this. Let me move this up. Okay. 1, 2, 3, and 4. There we good? Lines are maybe the easiest of them all because lines go in both directions forever unless they're contained, right? So if you see the arrowheads here like there are on this question, there's no containing a line. It's going in both directions forever and ever, always, right? So you get to write both these as like the domain is just going to be x is a part of the real numbers, right? And the range is the same. Right? If, however, I decided to say that I was going to contain the graph at these points, then you could draw a box around it, right? Then I could draw my box and say, okay, well, I can't go less than 10, negative 10, or I can't go greater than positive 10. So then you would just adjust your domain and range to look like these ones, right? If that were the case. Okay. Now, for the purposes of the next one, we'll scroll down here in the bottom. Okay. Originally, I wouldn't have had any grid lines there for you. I added the grid lines. Okay. But you can get a pretty good picture, right, from just the equation itself. Okay, so if I'm just looking at this for what it is, what kind of graph is that? The first one. It's a line, right? So, and it doesn't state any restrictions on which I could plug any particular, like there's no restrictions on what I have to plug in there, right? I could plug in x equals 3 million, or I could plug in x equals negative 0.5, right? So because I recognize that it's a line, I don't actually have to graph it. I can just recognize the fact from here that lines, unless contained, have these domain and ranges, right? So I just get to write the domain, right? And the range is going to be now you could plot those if you wanted to, if you didn't believe me, right? That's why I put the grid lines there, but you don't actually need them. What about the next one? You would have spent a lot of time in grade 10 doing this sort of stuff, right? Maybe not the 2Ps, but, and we'll do this later. We'll definitely we cover our basis in this 3M course, and that's what's great about it is kind of get to go back and revisit some stuff, right? So what kind of graph is this one? Anytime I see the square, it's a parabola, right? Just a quadratic, right? So the original quadratic looks like this. 0, 0, 1, 1, negative 1, 1, 2, and 4, right? Negative 2, 4. There's your original parabola. What's happened to this thing? There's a whole bunch of transformations on it, right? So it's moved to the left 1, and it's been moved down 6. That's really the only two that I really care about, right? The vertical stretch just changes the y. The y values just get bigger, right? But it's going to infinity in the y direction anyway. So just because I stretch it doesn't change anything, right? The y values are still just going to go on forever. So I'm not actually too interested with the 3. What is interesting, and I almost forgot about it, is what? The negative. What does the negative mean? It flipped it. That changes your domain and range big time, particularly the range, not so much the domain, right? So if I reflect this thing now, I'm just going to do a quick sketch of it, right? I know I have to reflect it, which means it's going to go something like this now. Right? And then I could multiply the y values by 3, but this doesn't really change anything, right? Because it's still going to go continuous forever. And then I'm going to move it to the left 1 and up 6, right? So my final graph's going to look like left 1, up 6. And then the step pattern would change briefly, or kind of, but from 6 to 2. It's hard seeing this. Okay, so there's your transformed graph, the green one, right? And then you just write domain and range off of it. So the domain, what's the domain for a parabola?
It's goes on forever.
It goes forever in both directions, right? So you just get the right XER. And with the range, there's one stipulation with the range. It's never going to go greater than a particular value, right? It's the maximum value on the end. Can't go any higher than 6, right? So the range is going to be y is a part of the real numbers such that y has to be less than or equal to positive 6. Okay? Make sense? Okay. And then the last one, if you were to plug in values here, this is we'll do this again later. This little square root, this is called the root function, right? Which I like to signify it as the hook. This is what my grade 11 teacher called it, right? So it's like this. If you plugged in points into like y equals root x, you would get this shape. And you select specific ones strategically, right? So I pick square rootable numbers, so I can square root 0, I can square root 1, and I can square root 4. Those spit out y values of 1 and 2, because the square root of 4 is 2. So this is where this sideways parabola thing comes from, right? And then what else we'll do, this graph's also going to get reflected in the y-axis and then moved. But that's not really that important, right? It is important for this context, but if we were to plot this, right, it would have to get reflected in the x. It would have to do something like this now, right? And then it's going to get moved. It's a little bit different, this one. I'm just thinking ahead. You guys don't need to particularly, I won't ask you this on like the first unit test, but it's going to move to the right too. It's going to move to the right too, okay? So it's going to end up over here. Your final graph's going to be right here. Something like this, okay? The magenta one. So then the domain, you can contain the domain, right? It's never going to go greater than x equals 2. So then you get to write the domain is x is a part of the real numbers such that x has to be less than or equal to positive 2, right? And then the range, it's sitting on the x-axis. So again, you can't go any lower than the x-axis. So y has to take on values greater than 0 or equal to 0. That make sense? that's all I got for you. Okay, and I'll give you a worksheet. And if you guys finish the worksheet, we can take it up before the end of class.